A science lab is a place where you can do stuff. Instead of writing down everything on pieces of paper, you actually get to carry out the experiments and see the results float out in front of you. However, it's important that you be safe. There are a lot of dangerous things that can happen in the science lab. So for your own safety and the safety of those around you, my class and I have put together this little safety video so that you know how to be safe and to follow the safety instructions. Appropriate lab wear for science labs include your safety goggles, rubber gloves, and a science coat.
Ew, what's that smell? It smells so bad in here. Is that acid? Want to check?
Whoa, wait! If this is a really dangerous acid, those fumes would have gone straight into your body, and who knows what they could have done from there. To properly identify an acid by its smell, we use a technique called wafting. What you do is you just kind of take your hand and you just... And from there, you'll still get the fumes, but it won't be nearly as much as what these two just got. Class! What is this? Nearly everything here has nothing to do with the lab. This is a mess. We need to get this cleaned up. Remember, the only things you need for a science lab is a pen or a pencil, your calculator, and your lab notebook.
Sometimes in lab, you'll come across working across a crucible. I'm going to show you how to set it up properly. First, to set up the ring stand, you're going to need to place the ring appropriate distance away from your Bunsen burner. Okay, so I'll just eyeball it right here. I think this is an appropriate distance. And then I'll just attach it right here. Then you have two options. You have option A, your wire mesh, which just goes on top right here. Now, the disadvantage of a wire mesh is you probably won't have as fast of a time to heat up whatever you put on it. So the wire mesh is good mostly for beakers and flasks. Or you have option B, which is the triangle, which is better for us in this case. Make sure that when you place the triangle on the ring, that the little metal tips point up rather than down. It's more stable this way. Okay, and now you have the actual crucible right here. As you can see, the crucible fits just fine in the triangle. If it doesn't fit just fine, you can always just push the triangle more in, like so, and you can still place it and it's still stable. Now, the first time I ever worked with a crucible, I took my tongs and I took the lid off like this, which is fine. It's a little shaky, but it's fine. But then I looked at it like this, and I was like, okay, that's actually not what you're supposed to do at all, because the second time I did it, I dropped it and it shattered all over the place. So, I asked my teacher to demonstrate the correct way to pick up a crucible, and she was like this. Whoa, amazing. I do not advise that you like turn it upside down or shake it a lot, because this is still not quite as stable as you think. But with a firm grip and, you know, common sense, I guess you can still place it on top of the triangle properly over a burning flame. And then that's when you can just put your lid on top and you can let your experiment run.
Whoa, careful. Do you know what sort of chemicals could have been on this table before you ate that apple there? Look at this. In science, we work with lots of different dangerous chemicals, and as usual, they'll probably get all over the table. So when you ate that apple just now, you could have eaten some of those dangerous chemicals that might have been not properly cleaned off the table. Never eat or drink in a science lab. Whoa, wait, this is a science lab, not a playground. If you were messing around with these dangerous chemicals like this acid or this lemon ammonia or anything else that could potentially be corrosive to skin or eyes or anything else like that, you could potentially get hurt. Please, no horseplaying in the science lab. Aren't you a little old to be in this class? While working in a science lab, there's a chance you may get dangerous chemicals in your eyes. If this is the case, you're going to need to use the eye wash station. Open your eyes up wide, turn on the eye wash station, and put your eyes in there for roughly 15 to 20 minutes. After that, seek medical attention immediately. Take a look at these two chemicals. This one is potassium chloride, and this one is potassium chlorate. They both sound alike and they both look alike, but they both react very differently. Let's see how.
Morning everybody, this is Miss Gill. I'm going to show you the correct way to light a Bunsen burner when you don't have a striker near you. So the point of lighting the Bunsen burner is the gas is on, but you shouldn't turn on the Bunsen burner, because if you light the match after the Bunsen burner is on, everything is going to go up in flames. So you need to light the matchsticks first, then you slowly turn on the Bunsen burner, and then you turn the Bunsen burner on. And that's how you correctly light the Bunsen burner with a matchstick. Now I am going to demonstrate what happens between when you melt potassium chlorate versus when you melt potassium chloride. They both sound somewhat similar to each other because they both have potassium metal in them, but they both react completely differently from each other. While one is going to melt pretty fast with the Bunsen burner, the other one doesn't melt so fast. As you can see at the very bottom of the test tube, it is actually starting to melt. At the top, it's still powdery. That's why the correct way to actually melt something is constantly keep going back and forth on the test tube while the test tube is tilted away from you and your partner, so that the whole powder or whatever you're trying to melt gets equal amount of heat on each side. You can't just keep it on one side at the very bottom, because then it's going to just burn the bottom part off and do nothing to the top. As you can see, this is almost gone. So this is potassium chlorate. It's almost melted completely. There's just this little tiny piece that I'm having to melt. Once it's done, we are going to move outside the classroom because we can't do the rest of the experiment in the classroom.
Following experiments is very dangerous. Remember, safety goggles on at all times. Go for it, Miss Gill.
As you can see, this experiment cannot be done within the classroom because it produces a lot of gas. Usually it's done with a gummy bear. Since I didn't have a gummy bear and it's mostly made out of sugar, I put sugar there instead. This is an experiment to show burning of sugar. And since it produces so much gas, I cannot have it done within the classroom, so we always have to come outside to do it.
So you've already seen what happens to potassium chlorate, but what happens to potassium chloride? Well, it doesn't necessarily heat up that well. In fact, the melting point of potassium chloride is about 770 degrees. Therefore, once exposed to a Bunsen burner, this thing will take a very, very long time to melt. It's been quite a long time, and the potassium chloride still hasn't melted yet. This shows that it is a very different chemical from the potassium chlorate. So now that you've seen the big difference between these two chemicals and how they react, even though they're very similarly named, you should know that it's very important to read the labels and be careful when you're doing science experiments, okay? Two different chemicals with very similar names can react very differently and can change the results drastically.
You know, you know what essay is?
I have, but bro, how do you do the in-text citations? Like, I don't know how to do those at all.
I don't know, just Google it.
You
Shit,
did?
give us some knowledge.
Oh shoot.
Whoa, careful! This is a Bunsen burner. It produces a gentle flame. And if it was on, your hair would have just caught on fire right now. And as we all know, fire isn't necessarily good for your hair or your health. Please be careful when working with Bunsen burners and open flames. And always tie your hair back in a knot like this student is doing.
Hey, what are you doing?
What?
That's not how you do that.
What? What do you mean? Aren't you supposed to cut towards your body?
No.
Whoa, Kevin, you're about to cut me! Here, I think this is how we should do it. Remember, when dissecting a cadaver, it is important to have respect towards the life sacrifice towards science. Also, even more important, cut away from your body and away from your partner. That way, no one gets hurt and the lab can be a success.
Wait, that's a good.
Whoa, stop! In the event of broken glassware, do not attempt to pick up the glass by yourself. Instead, stop whatever you're doing and inform the nearest teacher.
I'm gonna clean that up for you.
Thank you.
Accidents happen. Just make sure you don't hurt yourself. There we go.
Dress code violation.
But I look so good though.
Appropriate clothing for a lab environment are closed-toed shoes, no loose clothing, hair tied back, and no dangling jewelry.
Hey Kevin, you wanna drink some lemonade?
Yeah.
Alright. Here you go, buddy.
Katrina.
Mira, dímelo, long time no see.
Pues, ¿qué quieres?
Pues ya tú sabes, let me get that HCl highly concentrated.
Okay, sis. You want anything added to it?
Add that the potassium to make it healthy.
You want chloride or chlorate?
Make it both.
Both? Okay.
A little more, a little more.
A little more. All done.
Órale, gracias, comadre.
Remember, working in a science lab is a privilege, not a right. So make sure you please follow all safety instructions and be careful. If you do, you'll find the results to be quite legendary.
Accidents happen. Just make sure you don't hurt yourself. Got it.
Okay.
Still some more. There's still a bit
I
more.
know.
That's okay. We just
This is a mess. We need to get this cleaned up.
Wait, that's like
Good job.
Delete all the other parts so you don't get mixed up, and then that was good. Keep.
Go.
Hold on. Can you like move there once I'm there? Okay, I'm ready. Like once I'm there, no, you move there.
Have it on.
Oh, I should check this. Expression so clean, clean. So sexy, I just so expression so clean, clean. So fresh and so clean, clean. I'm so sexy.
Go.
I think it's too wet in there right now.
Go.
Ew, what's that smell? Is that acid? I don't know, let me check.
Whoa, wait.
No, okay,
If this...
Go.
Ew, what's that smell? Is that acid? I don't know, let me check.
Whoa, wait. If this was...
Should we, I would say, should we check? Okay.
Go.
Whoa, wait. This is a science lab, not a classroom. Oh.
Go.
When working in a science lab, there's a chance that you may get dangerous chemicals in your eyes. If this is the case, you use the eye wash station. Make sure you open up your eyes wide. On. Wait, we need to wait for everyone to stop talking.
Stand, and you find an appropriate height from
From the button.
the button. No, this is the ring stand and this is the circle.
This is the ring.
The ring, but that's the stand.
Yeah.
Okay.
So I mean, you could say.
Whoa, what are you doing?
What?
That's not how you do that.
What do you mean? Aren't you supposed to? Kevin, you pushed me too early.
Oh, man.
Oh.
In the event of broken glassware, this is taking...
I'll do a separate.
I don't know what I'm doing. I'm just standing here.
Wait,
to give us a...
Okay.
Class!
okay, it's like
What
really
is-
quiet and awkward. What should be going on?
So that
You're
we have to
so
look
tall.
real.
Like,
Am I
do you
too
want me
tall?
to go up? Like,
Class! What is this? What does this or this or this. What are you doing? What does any of this have to do with the lab?
Standing in.
Yes, because that's where she told me to stand so I could bathe the camera.
God, Gary. Gary, you're in two takes. Restart.
You get
Class!
Clap.
Restart.
that was a good response though. That was so good. Don't laugh the next time. Do the same thing again.
Okay.
Class! What is this? What does this or this or this or this have to do with the lab? What were you doing with that water bottle? Why did you just... This is a mess. We need to clean this up. Here.
Let me just show you what it looks like, okay? Like from here.
Just say go.